Right, here we go. So we're doing this question really this time. Represent the constraints graphically. That reference won't work, will it? Anyway, shape the regions where the inequalities are not. Right, we know how to draw these. This is easy, but some people did crazy drawings. 3x minus 2y less than or equal to 12. So we're just going to think through how we might go about drawing that. We did this. One of the easy ways of doing this is to think what would happen if x is 0 and y is 0, and just kind of pick values and join them up. Don't get into too much detail about doing this. So 3x minus 2y is less than or equal to 12. If x equals 0, oh, that's going to be awkward, isn't it? Y would be minus 6. If y is 0, x would be 4. We could do with another value, couldn't we? If we think about what else would happen, let's just pick another sensible value. If x is 8, then we would get y. This would work this time, wouldn't it? We'd get 12 to 24 is minus 12 divided by minus 2, so y will be 6. So we've got a line that goes to the point 4, 0 and 8, 6. It's really hard to see where things are going. Is that right?
Yeah.
Luke? Okay, so there's our line. Missed. There we go. We need to shade the region that we want to reject. Donch. So if we take the point 2, 2, for example, 2, 2 would be 6 minus 4, which is less than 12. So that is the accept region. So we're going to shade the reject region over here. Oh, it's going to take forever doing like that. There you go. Shade. Right, the next one. 3x plus 4y is less than or equal to 30. 3x. It's just time consuming, isn't it? X is 0. Y would be 7.5, good. Y is x is 10. So 0 there and about there. There we are. Join it up. We got that. 1, 1 satisfies that, so we're going to reject the other side. Where's it gone? It's one of the worst drawings I've ever done. Right, next. 3x minus 8y is less than or equal to minus 24. Right, that's rearranged. So 3x plus 24, I'm doing some different stuff this time. Felt like a change. So 3/8 of x plus 3 is less than or equal to y or something. So it crosses at 3. That's a good start. Aha. And what can we say? Well, if x was 8, we'd have 3 plus 3, 6. There we go. So we're going to draw it. Like that. Oh, this is looking great, isn't it? And do this with that. Shade it in. There we are. Right, so we're left with a nice little region. Bargain. Right. Done it. Thanks. Calculate the coordinates of the vertices of the feasible region, apart from the origin, and calculate the value of P at each vertex. Hence find the optimal values. Right. So we need the points where things are intersecting here. It does say calculate, but you know we can get these from the graph. We know what we're doing with this stuff. So this is this is A. Let's call this A, B, C, and D. And let's work out what these points are. The point A is the point 0, 3. We know that from what we did when we set up the equations. P is 5x plus 8y. So at A, P is 0 plus 24, which is 24. At B, there's B. Hi. At B, well, what is that point? My graph isn't amazing, but it was clear on the other thing. That is actually the point. That is 4. X is 4. And the y value, again, you can kind of see it from what's going on there. It's 4.5. We could calculate it. We could do simultaneous equations. But for the amount of marks that we've been given, just 4 marks for doing this, I think it's all right to get it accurately from the graph. So we've got that point. P is 5 times 4 plus 8 times 4.5, 20 plus another amount, 56. It is. It's a shock. Right, C is 6, 3. P is 5, 6's plus 8, 3's 30, 40, 54. And D is the point 40, so P is 5 times 4 is 0, which is 20. We've got our values. So the maximum value of P is 56 when x equals 4, y equals 4.5. Fantastic, great, we're doing brilliantly. Now, this question asks things in such an odd way that lots of people got caught out by this. Suppose that additionally x and y must both be integers. Find the maximum feasible value of y for every, they've put it in bold, I'm going to add to their boldness with a green, for every feasible integer value of x. Calculate the value of p at each of these points and hence find the optimal values. So for every value of x, we need to find the maximum feasible value of y. It's not enough just to look, around our extreme points. Well, x can be 0, 1, 2, 3, 4, 5, and 6. So I've got a lot of work to do here. I'm going to do a little table with green dots. Ooh. And how fancy. X is 0, 1, 2, 3, 4, 5, 6. And here's our table. The maximum y value for each of these, I'm going to read off my graph. If a is 0, it looks like it's 3. If x is 0, it's 3. If x is 1, we're there, it's still 3. If x is 2, it's still 3. If x is 3, that's about there. Oh, we're 4 now. Great news. If x is 4, I already know this is going to be 4 because it was 4.5 when we did it before. If x is 5, my maximum value, it's less than 4, so it's now 3 again. And if x is 6, it's 3 as well. So they are my maximum y values for each of those integer values of x. And I need to work out p. P, remember, was 5x plus 8y. So if I calculate this all the way along, 5 zeros plus 8 threes, this would be 29. This would be 34, I think. Here we'd have 32 plus 15, so 47. And here we'd have an extra 5, so 52. And this one would be 25 plus 24, so 49. And here we'd have an extra 5, so 54. 4. Yes. So now the maximum value of P is 54 when X is 6 and Y is 3. That was really awkward because you see, we've not really seen this before, have we? That we had to actually, the question did it and they even did a bold little bit of type. But for every single X value we had to find the maximum integer value of Y and go through all of that. And we had to get all of these P values to do it. Lots and lots of work. So, now, having done that, Tom wants to use the Simplex algorithm. Well done, Tom. To solve the original non-integer problem. He reformulates it as follows. Explain why Tom needed to change the third constraint. The third constraint previously said 3x minus 8y is greater than or equal to minus 24. He's changed it to minus 3x plus 8y is less than or equal to 24. Why did he need to change it? Well, when we formulate the Simplex algorithm, we need to be able to add a slack variable. So we need, we need these values to be positive numbers so that we can introduce a slack variable and have positive values on the right hand side. So we need and to add slack variable. So it was about making that minus 24 into a plus 24. Represent the problem as an initial simplex tableau. Now I always find it slightly awkward the way that they split the questions here, so I kind of merged what I did in parts 5 and 6, but I did want to write out the equations before I put it into the tableau, because I'm used to doing that. So we have that, then we're going to introduce our slack variable, we call it R, and we have 3x plus 4y plus s is 30, and minus 3x is gone, plus 8y plus t is 24. Right, we're ready? Okay, so let's tableau this thing. That could be my new catchphrase. Team of Are you even a verb?
No. He's a noun. Or he isn't. But that.
You just said he is a noun live on YouTube.
Like an idiot.
Oh no.
Yeah, James looks like the idiot here.
Literally, single figures of people are going to watch this.
You get double figures sometimes.
Sometimes.
It's going to get loads of hits now.
I have a special video.
You have people watching from around the world.
Well, yeah, the Australian guy. Right, we've got. Let's put this into the table. Shouldn't talk about it. Right. Minus 5.
He's our Australian #1 fan.
What's his YouTube name?
I'm not allowed to because of the court case.
He's lost a follower.
There's no court.
You've lost half your views now.
Yet. Oh, right.
What, Dave?
I heard something about Vladimir Ponchowski the other day. Just a rumour.
Oh, what was this? What was this rumour?
It's someone here.
Yeah. Right. Hey, James. So
I don't know what you're on about.
we've set up our initial simplex tableau. There we are.
Who are you speaking
Where's
to?
Victor?
Were you speaking to Will?
Yeah.
Sam cannot keep anything to himself.
Was it actually
Are you
you?
actually Vladimir?
I'm Vladimir
Oh.
Control.
Did you make up the
I made
birthday
it,
bread sister? Because
Yes.
Victor said that that's a thing in Russia.
I checked the forums.
No way.
Oh,
I
yeah,
did.
you really did just put one offence.
If Will wouldn't have given it away, I was going to have a whole, chat set up between Vladimir and Dave, and have like a.
This is all on the video. Let's carry on. We'll talk about Vladimir and his problems later. Now, we've done it. We've done this bit. Hooray! Perform one iteration of the simplex algorithm, choosing your pivots from the Y column. Right. So they've told us where to pivot. Don't. And we
Could it be like a pivot of on a. That's what Dave was getting at.
Is this video going right now?
That's what Dave was getting
Are we
at.
still recording?
Yeah.
Like
I'm being
pivoting on
right.
something.
12 over. Now remember.
Ballet?
Netball.
Netball?
No, pivots in like...
Turn round.
Right. We divide by these numbers, but not if they're negative. Remember, we mustn't do it if they're negative. So we don't do 12 over minus 2. Did you just move the video? 30 over 4. We do that.
We do.
24 over 3.
Do.
We do that.
24 over 3.
8. 3. 8 is 3. Oh.
Too quick, Dave.
Stop it. There we go. There's the pivot. Hooray for that.
Hurry for what?
I might not upload this one.
You just have to cut that off.
I think you'll get more views.
It is currently 17 minutes long.
Right. There's number 5. It's
Who would
Friday
want 17
afternoon.
minutes of algorithm?
It's our last ever Friday afternoon.
Oh.
You should sing your Friday song.
Yeah, because my Friday song exists.
Oh, when is your song?
Next Thursday.
I've be there.
I've got an exam next Thursday.
Looks to be
Will I
you.
miss it?
No.
Okay.
It's in the middle.
Have you wrote the birthday yet, though?
I haven't written any. Look, we're doing a question. I haven't
Have you
written any
been
verses.
procrastinating about doing it?
Yes.
Is there one about me?
Right, so we've set up that. We've got the one that we wanted down there. Now we've got to sort out the other rows. Row 7 comes from row 3, and we're going to take away 4 lots of row 8. Now, I had to use a calculator. I got
Generally what you do.
0. No, I do it in the other pen.
Oh,
0. 9 over 2. 0. 0. 1. Minus a half. And 18.
whoa.
That's what Dave got. And then I did 6. Row 6 is row 2. Look, we've got a minus 2 there, so we need to add 2 lots of row 8. So that gives us, are you ready for this? 0.
I'm ready.
9 over 4. 0. 1. 0, a quarter, and 18. Row 5 comes from row 1. There's a minus 8 there, so we need to add 8. 8s, 8 8s. Not 64, it gives us 1. Gives us minus 8. 0, 0. 0. 1. 24. Phew. That is one iteration performed. Write down the values of x, y and p that result from this iteration, okay? I will. P is currently 24. X is 0. We've got zeros in that column. Oh, we've got numbers in that column, so it's 0. And y is 3. There we go, so that's where we are at the moment. Then, Constraint on the question, Georgie. Then we have to do another simplex iteration. Oh no! Right, we haven't got a choice of pivot. We have to pivot on the most negative row on the top column. When we calculate these values, we're going to do 18 divided by 9 over 4. We're going to do 18 divided by 9 over 2. We're not going to do 3 divided by minus 3 over 8, because that would involve divided by a negative. We don't do that. These give us values of 8 and 4. That one's 8, that one's 4, that one's the smallest. So there is our pivot. And now we do the whole thing all over again. It's horrible, isn't it? So, 7, 8, 9, row 11 is row 7 divided by that number, which gives us 0.
1.
What? Good. 1.
0.
0. 0. 2 ninths. Minus a ninth. And 4. Right. Row 10. I don't know why I'm doing row 10 next. Is row
7.
row 6.
7, isn't it?
No, that was from row 7.
Oh.
Oh. No, yes, minus 9 over 4 times 11. Giving us a ridiculous question. 0, 0, 0, 1, minus half, half, 9. Row 9. Came from row 5, and it involved us adding 8 plus 8, row 11. I'm bored. 1, 0, 0, 0. I'm just doing it quickly now.
So you're laughing before I am there.
I don't know what that number is.
Has it got too much to
That might be 16 over 9, or it might be 10 over 9. It doesn't matter. That's the thing, it doesn't matter what numbers you get.
I'm taking part in the count.
Exactly.
Even maths.
Right, this is what you end up with. Something like this. Approximately.
Shut up.
There we go. Oh look! Oh look! The top row is all positive. We've finished. Thank goodness. So the maximum P is 56. Of course it is. We already knew this. Because it's the answer we got in part 2. Years ago. X is 4. Y is 4.5. If you remember very much earlier in the question, so much has happened since then. We got those values, didn't we, in the second part? That was it. What a thing to drag yourself through at the end of the paper.